Thanks, Ayush. Hear me clearly and see me?
Yeah, Kashif.
Awesome, awesome. Let me share my screen. I'll start with the presentation first, right? Uh,
Yeah.
a very good evening to all of you. Like, uh, you know, Ayush said, my name is Kashif, and I'll take you through this presentation of aluminum fuel cells by Log9 Materials. Um, Let me quickly set the background first, right? What Log9 Materials is all about and what we have been doing in the past few years. We are a deep tech company that was established in 2015 and by two IIT Roorkee graduates and Mr. Pankaj Sharma, Akshay Singhal, and Karthik. What we've done is that we started out with developing graphene material. This wondrous material was later commercialized by Log9 into one of those oil absorbent pads. Uh, Not only that, Log9 stint into energy storage and energy building devices have come a long way. We've been able to put up India's first cell line, so to say, and then we started about building batteries for two-wheelers and three-wheelers and energy storage devices. In one of these contexts, one of our technology that we presented to the world in 2019 was aluminum fuel cells, and we will discover more about it. So, there's a vision, mission, and purpose behind every deep tech company, and what is it all about? So, what we do is that our vision essentially is to be the most respectable clean mobility brand and energy brand across all sectors by 2030 across the world, as well as in the tropical countries. Essentially, tropical countries because the technology that we develop here is rather really hard to be custom fit in all across the world. So, you really build for the tropical world, but you're building for the world, right? How are we going to do that? We are powered by deep tech innovations, not just aluminum air battery that we are building. We're building, lithium ion technology. We are building battery solutions for two-wheelers, three-wheelers, energy storage devices, and all of that covers under energy. And the whole purpose about it is, understanding that in past 100 years, we've been doing a lot of, humanity has come a long way, right? We've gone out from walking on the streets to flying in the air, but in this tryst of reaching new, um, you know, realms of innovation, we've done is that we've warmed up our planet by emitting so much of carbon emissions inside it, right? We've kind of destroyed our own home. So idea for Log9 is to branch away from that thought and go towards a sustainable, more climate-friendly path, right? This is the whole storyline of Log9. Where did we start, and today where we stand at, right? So let's start from the zero, right? Let's start from the base of everything. Um, what is net zero and why is it important? Everyone keeps talking about we need to achieve net zero by a particular amount, and there needs to be stoppage in net carbon emissions that we are doing. To give you a background, right, what today we are doing at least 40 to 50 gigatons of carbon dioxide emission in the whole world. Now, what leaves us with that is that there's a 67, according to a report, there's a 67% probability that we will reach a target of 460 gigatons, right? That's a hard cap. So if we reach that 460 gigatons, which is a hard cap, let's say by this rate, it will be 10 years, 12 years maximum. What's going to happen is that our global average temperature will increase by 1.5 degrees Celsius. Now, why that's bad is that, this will initiate the destruction of coral reef. First thing first will happen is that the coral reefs are going to go bad. They're a very essential part in aquatic life and, the amount of balance that we have presented in this world. Secondly, there will be permafrost thaw. What happens is that these large, ice melts are going to happen, which will result in, extremely dangerous microbial, life to be coming into picture, which might not be good for the planet. This also increases the sea levels and whatnot. The crop life is going to go bad. Now that's 1.5 degrees Celsius. You go a little bit more ahead. We don't change our ways. We just keep it like that. you will start seeing wildfires like that in California and Australia that happened in the last few years, common all across the world. Your desertification of the land will happen. That is going to essentially imply that, food supply chain is affected and whatnot. We essentially don't stop there. We continue putting more and more carbon in the world. What happens is that, you're looking at unpredictable weather and the planet being left uninhabitable. So what the world is doing about it, right? All of this net zero to be achieved, what the world is doing is that it's building more and more renewable technologies. It's getting its hands away from carbon emitting technologies and going towards more and more net zero tech. Now, this net zero tech, like for example, solar or wind, they create a essential new kind of a problem. The problem is called of duck curve. What happens in a duck curve problem is that essentially you build so much of solar energy that you're producing at some point of the time, you're producing more than you are required to. This leaves an alternative, this leaves an overproduction gap. So here you would need more and more grid storage and battery storage technologies. How do you achieve that is by, there are various alternatives, right? You can do pumped hydro, for example. You can do, uh, you know, energy storage like in lithium ion. But there's a metrics on which you select what technology will be suited for this kind of an application. And then is what we are talking about, a Ragon plot for energy storage devices. Energy market is always defined by two factors, right? Power density and energy density. How much can you store? How much can you supply in a shot? Uh, you look at the more power dense application. There are supercapacitors, ultra capacitors, ion capacitors. And then you look at energy dense technologies, lithium, lead acid batteries, metal air batteries. So what happens here is that you need to define what is your end use case application, and only according to that you select what kind of tech will make more sense and where it needs to be fit. So in one of these technologies, more and more energy dense technology is one of the alternatives you can put down is metal air batteries. What happens in a metal air battery is as shown on the screen, right? It's an anode material, which is essentially a metal. You have air electrode, which takes the oxygen in the surrounding air, and these two react to produce energy. A simple chemical reaction is shown below. Now, why these technologies are viable, or why do these technologies seems like a good idea to be pursuing with? They are long duration. Your typical lithium ion storage runs for 4 hours, 5 hours. They can give you instantaneously high power, but they can run for 4 or 5 hours. Your metal air batteries can run longer for 12 plus hours. There are technologies that can run for 24 hours as well. You have wide operating range, temperature range, right? There is nothing like you cannot operate between a certain temperature. You can set it to a higher temperature or a lower temperature. That also means that there is no risk of thermal runaways, which brings me to the point of increased safety. Now, when we are talking about safety, metal air batteries essentially does not contain anything that is flammable. It's aqueous liquid electrolyte, right? So no flammability, no thermal runaways. And on top of it, it's resource diverse. You're looking at elements which are commonly available. You're looking at oxygen, which is essentially there in the world, and elements which are mined since ages and have a high earth abundance. Now the question is which metal air technology to be chosen between. There are so many of them. There's iron air, zinc air, magnesium air. All of them are listed down here. You can see there are two kinds. Essentially, I can divide them in two kinds. Right? One is the aqueous electrolyte, where the electrolyte is essentially an aqueous media. And then there are non-aqueous electrolyte solutions like lithium air, sodium air, and potassium air. The higher the competition is between aluminum and lithium. And what happens here is that lithium air is typically a little unstable technology when compared to aluminum air. And why aluminum makes a lot of sense is because its abundance in the world. Top three elements that are present in Earth are oxygen, silicon, and third is aluminum. I'm not sure about the first two ones, right? So aluminum is essentially 8.1% of Earth's crust. And that essentially makes sense, right? You have high energy dense technology with high abundance in the air. seems like a good solution to go ahead with. Now, what we have Logline has done is that we've built the exact same technology. We've taken um, essentially aluminum anode on one side, built our own air cathode, which has a current collecting element, which you can see on the screen here. What happens is the current collecting element takes the oxygen from the air, converts it into OH minus ions. The OH minus ions react with the aluminum present there. It generates this electrode potential on aluminum, which is essentially the energy that we have. So this is the chemistry that we are talking about, right? We need to more and more talk about what is in it that makes it works, right? Essentially, what you need for this kind of technology, and I'm going to spend a little bit more time here, is that you would need a system to make it work, right? Essentially, this is a circular flowing electrolyte. It's not a stationary electrolyte that is going to be inside it. It's going to be a circular flowing electrolyte that needs to be inside there. What happens here there is you have a reservoir in the system where you store the electrolyte. The reservoir is then pumped into the cells, which are mechanically rechargeable. Now I'll show you how mechanically rechargeable is when I show you the exact fuel cells that I have. What happens here is that you take these aluminum anodes, put it inside, and then you run this, let the system run, which essentially is controlled using an onboard computer. This onboard computer is really, really important because it maintains that imperfect balance of aluminum fuel cell that we are talking about, right? You have, you need to make sure that the electrolyte is flowing in proper manner. Its flow rate is constant. Its flow rate is maintained using the pump. You have to make sure that the temperature that is going inside is maintained by the thermal management system that are there in out there. Um, you need to ensure the user that, okay, now it's the time you need to replace the aluminum that you've put inside it. There are essentially a whole bunch of power electronics come into picture where you would need to operate converters at very high efficiencies so that you do not lose the power in the system, and all of that is communicated and controlled using the onboard computer. So that essentially is the main primary focus of this technology, along with the along with the fuel cell stack, because it's kind of built in a way that ensures that the flow is even across the cells, right? It's a flow battery, so computational fluid dynamics is put a lot into use here. You need to ensure that the plates are consumed evenly. Your pump is selection needs to be done in a very particular manner. Uh, you need the whole pipeline to be not doing any cause of harm to the whole system. The material selection is really, really important. So it's an amalgamation of a lot of technologies that we are talking about here. And when we run this system on the left-hand side, you can see that what we get. This is the system that we have that delivers a constant power over a 9-hour period of time. You see the straight line. This is exactly from the report that we have from the in-house technology. What we've essentially done is that we've run this system for 9 hours, and this is the output of that system. Now, the technology is fine. What happens? How does it go back and help us, right? Essentially, what we are talking about is an existing supply chain of aluminum, right? Aluminum is already being manufactured by a lot of companies. Aluminum is already being produced, recycled. There's an established recycling process as well. What we're talking about is making sure that this existing supply chain is already run by renewable energy. The duck curves essentially that I was talking about, they are the excess energy is used to make this aluminum. And what we at Log9 are doing is that um, we are producing the fuel cell system. Now, if I go back on 2 previous slides, right, I want to stress somewhere. Look at this resultant here, right? What essentially is your output? You're getting aluminum hydroxide when you uh, run these aluminum plates. They get consumed inside the cells. So what happens when you run these cells, you get aluminum hydroxide. Essentially, what happens is in this loop, when you generate energy from these cells, the aluminum hydroxide gets sent back to the refineries. And this is the circular economy that we're talking about. So essential energy is being trapped inside aluminum, the excess renewable energy. It's made inside. What we do is that you take these you now have solid fuel. Aluminium becomes your solid fuel. You take it, you run it in your fuel cells, and then you run it in the either the mobility or energy storage devices, and you have this whole circular economy coming into picture. Now, this is what our system looks like. This is what a 1 kilowatt system essentially is, right? What we do is that we can run this system with aluminum plates for about 9 to 10 hours. Essentially, we are bracketing it at 8 to 9 hours, and we constantly can deliver 1 kilowatt of power. So essentially, at any point of time, you want to tap into these aluminum fuel cells as energy sources, you will get 1 kilowatt peak. Now we have the power electronics into the picture. We have all the mumble jumbles of electronics that are working together, which are giving us 48-volt constant. So this is clean DC source of energy that we have and no emissions from it. And we can run between 5 to 50 degrees Celsius. That's essentially the range that we decided for this system. We can do more or less, but that is again the consideration. How much time does it take? It typically takes about 10 minutes of time for this flow battery to start. What happens is you plug the system in and you kind of wait for 10 minutes to start the system. And essentially, this is where we can draw the power from the system. Fuel requirements are nothing but solid aluminum plates. I'll show you those plates in a while. And the liquid fuels is nothing but your water-based electrolyte, where you have water essentially, you put down the system and you put it inside the system, you pull the aluminum plates inside it, and you can start running it. And your refueling time is just 15 to 20 minutes. So essentially, pull it out, it consumed plates, put inside the next plates, put the water-based electrolyte, and you're good to go. Now, all of that through, what's our value proposition? What are we putting down? What are we talking about it? We're calling this technology safe because of particularly, sorry, that's me once again. So we're talking about this technology for being safe. There's no risk of thermal runaways, no risk of fire accidents, uh, nothing that contains flammable devices. What we are also talking about is this technology being scalable, right? All you need is more and more stacks, more and more aluminum plates. You put them together, you scale up the electrolyte size, you're getting more and more power output, right? Uh, Essentially, this is a smart technology. Why? Because we've built in Internet of Things inside it. It's fully integrated and connected with onboard computer. It has a modular architecture. So your one system, you put another one, you kind of chain it up together and you get more and more power. You put two 1 kilowatt systems together, you get 2 kilowatt of power. And the most important bit is everything that we use is fully recyclable. We do not use any rare earth or conflict materials. Essentially, going back to using the most abundant material that are present inside it. And where are we targeting with these sections? Where are we targeting with these particular fuel cells? We're looking at, essentially Log9 is looking at targeting two sectors right now, which is stationary power sets. You have these, carbon hogging diesel generators that are there in the world. You have on-demand energy supply solutions. You have telecom tower backups. Essentially, what we're doing is that we'll pull those things out, pull those energy solutions, and try to push our solution inside that. On the other side, uh, like I said, lithium ion can give you a power backup of about 4 hours or 5 hours. But what about long haul vehicles? What about cross country cargo vehicles? You've got to travel to a very let's say you want to travel to your hometown from a particular city that you're living in. That journey takes you about 10 to 12 hours. What are you going to do about it? And how do you electrify that fleet? Essentially, Log9's aluminum fuel cells can come into picture there. We can become solutions provider for long haul passenger vehicles and cross country cargo vehicles. Not just that, we can become remote charging stations. Essentially, if there is no grid presence there, if the grid is absent and you can't put solar because then you'll have to put a lithium ion together. You need to run for 24 hours. And for 24 hours on-demand technology, you can pull up a aluminum fuel cell charging station right in the middle of nowhere. So that's the two kind of sectors that we're targeting for. And going back to the climate bit, when we said what, how do we go back to becoming net zero? Essentially, what needs to be done is that, we're becoming, in India is essentially an 84%, we have an 84% of petroleum product demand, and we are a net importer, right? For aluminum, we have high deposits of aluminum in on India, and aluminum can essentially become an alternative fuel with lesser and lesser carbon footprint of it, and it can essentially, go back to the whole idea of becoming net zero when the circular economy comes into picture, and that's how we by one of these fuels replace these fuels by one of them as aluminum, right? That's essentially what I wanted to tell you. Ayush, can you see my screen if it's possible? Yeah.
Yeah, yeah,
Right.
Kashif. Okay, so now we'll take some questions from the audience. Like,
Yeah, Ayush, before that, let me just show them what I have bought.
okay, yeah, the live stream. So,
Sure.
yeah, sure.
Right. Can you see the screen right now?
Yeah, let me
Awesome.
just spotlight you.
Please.
Okay. Kashif, can you present your screen? Yeah, now it's fine.
It's better?
Yeah,
Right.
it's better.
So essentially, let me just adjust my camera angles, guys, to allow me to do this. This is what our fuel cell looks like. This is essentially the whole technology that I was talking about, the stacks that I had presented in the presentation. And, so these are sections here where the pipes and the electrolyte connections essentially go in. The whole setup is too big for me to go inside the lab and bring it out. So I said, let me bring this fuel cell towards. And the recharging bit I was talking about for 15 minutes, allow me to just, I'm not the strongest guy, you can see. This is essentially that. These are your aluminum fuels. These are your aluminum fuels. Take this, you have the stack here, this energy generation stack. This is very lightweight. What we do is that just connect it, align them together, and then you have essentially, that's it. This is your fuel ready to dispatch. Awesome. Thank you, guys.
Yeah. So, Kashif, we have prepared some questions from the responses we got. So let me just take you through them.
Sure.
Okay, sure. Okay. Okay. So we'll be having the Q&A now. So Kashif, what do you think? Like, manufacturing these metals would are also producing tremendous amount of pollution. So how do you like plan to tackle them?
Right, I go back to the same bit, right? Earth abundant materials, recyclability. We've chosen everything that has high recyclability. Everything down from the plastics that we put in inside the system to essentially our fuel as well, right? You have everything that can be essentially recycled. And what we are looking at from this technology, and when we're building something like this from ground up, uh, you have the full capability to decide, right, boss, I'm gonna make this completely recyclable. I choose the material, my team sits down. Our first criteria is, is this conflict material? Is this rare material? Is this cost is this cost effective? The I have to bring in the Indian mentality where we say no, boss kitna deti hai. So essentially make it as low cost as possible with focus on climate, with focus on technologies that are consensually recyclable. So everything that you look at here is completely recyclable, and that is what we are looking at in terms of technologies. So we are reducing pollution. I will not say, all of these, there's a concept of embodied emissions, right? Whenever you build something, whenever you manufacture something, there are carbon emissions associated with it. Our whole focus is to get these embodied emissions trapped so much and run these technologies longer so that they overcome their embodied emissions and become essentially carbon negative, not just net zero.
Okay. Okay. So let's move to the next question.
Sure.
So, what do you think? Like, how the aluminium fuel cells uh, compete with the other contemporary battery technology solutions? One example that was given is solid sodium batteries.
So sodium ion batteries, I think essentially are these guys talking about. I go back to the Ragon's plot, right? I showed you. There's a Ragon plot where you have things like essentially energy dense and power dense applications. So if, and I will not say that, these are better or faring enough. We will still have to pitch them together. If so, aluminum essentially, aluminum batteries are uh, where you want longer duration energy disposal. I showed you that
Yeah.
curve, right, where the curve is pretty straight, right? So you essentially have that much, you have the energy being delivered. You don't have more, you don't have less. The throttling today is not possible on the energy technology there. So you get that much amount of peak. But
Yeah.
with these kind of technologies like sodium ion or lithium ion batteries, you can always charge them or discharge them at different C rates, right? When I talk about C rates is, let's say you have a 1 kilowatt battery, you have a 4 kilowatt hour battery. So you can take at least, you can essentially take 4 kilowatt from 1 hour or run this battery for 4 hours for 1 kilowatt. But for aluminum air batteries, it's constant 1 kilowatt. So depends on application. Again, energy is completely a sector where you will have to choose, see what the end application looks like and where the cost economics make sense.
Okay. So, so adding to the previous question, like, can you comment on the efficiency of AFCs compared to those
Right. So
batteries?
I will not be able to give you the numbers. The numbers are proprietary. So, but we've been able to do it. We've been able to compete with a lot of metal air batteries, so to say. We've been able to. There is zinc air technologies. There is iron air technologies, right? So essentially, what you can do is that how much can you take out from the 8,100 watt hour per kg that is stored in the aluminum? So we are faring closer to a realizable value that is achievable. And that's why that is where the next innovation will come in, where the system that you see could even be
Yeah.
possible, could even deliver more power out of it. So you build the core tech and then you improve upon the chemistry inside it. So I think we are efficient, but we can do better.
Okay. So, what do you think? Like, how are you planning to scale this technology, and what are your future plans regarding this
Correct.
AFC, these
So
AFCCs?
essentially, like I spoke about, there are two kind of sectors we are targeting. One is the energy storage grids, right? ESS energy storage technologies. And then the next one where you have essentially what do you call it? Mobility and two-wheelers and sorry, four-wheelers and long-haul vehicles, not two-wheelers. They're dominated by lithium ion, so we won't be going there.
Okay.
In energy storage technologies like solar, for example, you have companies like ESS and other metal, air, and redox flow battery technologies that are coming into picture, which are essentially used for energy storage stack. You have so much of solar that is being trapped. But what happens when the intermittency is not there? What happens when there is no sun? Let's say there's winter, there's less sun. How do you store effectively more and more amount of energy inside one single for a whole period of time? And that is where we are targeting for a long duration energy storage technologies for the first. And then we go with four-wheelers and long haul vehicles.
Okay. So, let's take some questions from the chat box.
So, yeah, you can read out, Ayush.
Yeah.
If I can read out them, I can read them out. Is that fine?
Maybe let me just go through them once, and I'll read them out for you.
Hmm.
So, will there Abhik is asking, like, will there
Hmm.
be any overheating problem when these batteries will be used in automobiles?
Overheating when used in automobiles. So essentially, there's no thermal runaways in these batteries, right?
Okay.
If the temperature increases, you consume more and more metal. So that is why we have a thermal management system on board, which is essentially controlling the temperature of the electrolyte and nothing much. So it's very simple tech. Your car radiators and car uh, radiators are the most essentially the simplest tech that I can tell you that happens there. So that's where we are at. We can there's no thermal run risk of thermal runaways, and overheating is not one of those problems that we see.
Okay. So, Arijit is asking regarding the water, like,
Mhm.
do you like where the water contained?
Correct.
Where's the
Right.
water
So you
contained?
right. Can I share my screen again? I'll show you where the water is stored.
Yeah, sure.
Yeah, please. I can share. Yes.
Yeah.
Right. Okay. Let me just go there. Right. Show. Right. Can you see my screen?
Yeah,
Yeah. So this is
yeah, Kash.
essentially the place where we store our electronics and everything. This is your refueling section where you open it up, refuel the aluminum that is there. And this is the section where you have all the other management and onboard computer systems. This is the space from the back you can put in your electrolyte and take it out and rework on all those aspects. So that's essentially where we refuel the electrolyte. I couldn't get the whole system. That's why I got this particular address.
Okay. So, so Pranjal is asking like, in this industry of like how Log9 will be standing out from other like other companies,
In the energy industry or in just by aluminium?
like in the energy industry or electric vehicles industry.
Right. So what we at Log9 are doing is that we are working on 2 or 3 different tech, right? We have fast charging electric vehicles that we've already developed. So essentially when your other technologies, other companies make your vehicles charge at 30 minutes, 40 minutes, sorry, 1 hour or 2 hour, we can do that in 30 minutes, 40 minutes. These are 8 to 10 kilowatt hour of batteries. That is one section that we're operating. The other line is that we are building our own cell, right? Lithium ion. When we talk about lithium ion, you are essentially the majority of the world focuses on temperatures in, Western worlds where it's relatively the higher temperatures are not that high and the lower temperatures are fairly low. So your temperatures,
Okay.
sorry,
Yeah, I can hear you.
there's a background noise. Sorry.
Okay. Sure.
So, so what happens is that these are not built for essentially tropical world. So what Log9 is doing is that it's targeting this world, this patch of the world where tropical climates are something that essentially needs to be addressed, and that is where we are building this technology for. And then we have we fit our uh, batteries into vehicles, test them out for range and everything by providing custom solutions to OEMs. So essentially in an electric vehicle, your batteries are one of the most important components. And so we are targeting to be making sure that these batteries are well fit, reliable, and essentially efficient to be working out there. And then there is our whole sector of aluminium fuel cells, where there's a small team which is working on big techs, trying to achieve more and more climate essential solutions.
Yeah. So, Sashank is asking like, how will you like how Log9 or this technology can be pitched to common man so that uh it will be like normal technology for them. Like it can be no like they don't feel alienated about this. Like they don't feel like it's something else. Like
No, no,
it is good for them.
yeah, right. So essentially,
Yeah.
when you talk about using this tech, right, I have a very simple concept, right? If my technicians can use it, right?
Yeah.
If I have lab technicians who can use this tech, the user experience is designed around that. Okay. The user experience is not designed around the engineers and the tech savvy people. The user experience is designed around people who are more, who we would want to target, the mass scale, right? So we design the technology around them. We want them to use it properly. We want them to sit down and be comfortable about it. You know how they can be, भैया आज का काम तो हो गया, but We tell them, boss, you know what? We are more and more comfortable about it, right? Being more and more uh, ex, you know, excited about it. So that's where we are. The technology user experience, a core idea of designing it for the common people so that common masses can use it.
Yeah. Okay. So any
There's one question, Ayush. Someone said
yeah.
if I can join Log9 to build this technology. I'll tell you there essentially was a problem statement that we floated. There
Okay.
was something called as the energy thon that we had. Essentially, what Log9 does is that we floated a questionnaire, or you've heard about hackathons. You've heard
Yeah.
about all the hackathons for
Hmm.
software development and all of this. We came with an idea of energy thon, which was the climate tech solution. So we said, boss, if you can come down, there are a list of problems. If you can come down, solve this list of problems that are mentioned here. One of them was aluminum fuel cell as well. There was a particular challenge that we wanted to quit around it. Can you come down and solve this problem for us? Then we can essentially give you an offer. So essentially, that was one of the key things I think people missed. But I think we'll come back, come again next year, next year, and I can take part in
Okay.
it.
Yeah. So I think okay. So yeah. So Abhik is asking like is there any charge cycle of the battery uh, like how many times it can be recharged or something?
No, so this is mechanically rechargeable, right? When your aluminum gets consumed, you remove these aluminum out, put your new aluminum inside it, and you're good to go.
Okay.
That's essentially recharging it. That's essentially charging it, recharging it. How do you charge it? You take aluminum right from solar.
Hmm.
You have this consumed aluminum hydroxide, you take them back, you put it together inside, you just give it back to the smelters. Those smelters will again pull it back into aluminum. There's an established recycling cycle already there. So the whole recycling is done for the better of the world, not by a small amount here. But these are mechanically rechargeable batteries. So you just pull inside your new aluminum cassettes and you're good to go.
Okay. Yeah. So hmm.
Start for $9,000.
Okay. So I thank Mr. Kashif for exhibiting this technology to us, and for I also thank the audience for providing such interesting questions. And so the session ends here.
Thank you. Thank you so much.
Yeah, thank you, Kashif.
Awesome. Thank you.
Uh, Guys, you can follow Kshitij on various social media platforms, and the links to our social media platforms will be provided in the chat box only.